Hello, everyone. Thank you for coming to my session. I will talk about large-scale personalized comment ranking system. My name is Zhe Jian. I have been working at TikTok as a machine learning engineer in recommendation engine for about a year and a half. I'd like to start my presentation with a quote from Laura Page. Artificial intelligence would be the ultimate version of Google, the ultimate search engine that would understand everything on the web. It would understand exactly what you wanted and it would give you the right thing. So Laura is talking about Google search engine here. But for recommendation system, we also want to give you exactly what you wanted. And we want to recommend the recipe. So here is the example of a comment section at TikTok. So you see people can post comments, people can interact with comments by like it, by reply to it. And people can also make video replies. So I want to start by justifying the value of comment section. So to me, the comment section provides three most important value: content, social, and signal. So comment is a form of user-generated content. On top of the short-form videos, creators post extra information in comment section, and they can share it with the publics. Social. So comment section provide user a space to express themselves and building social connection through like, reply, and share. And usually this can turn bonds from stranger to follower to fans and create mutual connections. And finally, signal. Comments provide strong signal to reflect the quality of videos. Such signals are used in recommendation engine and social interaction and trust and safety areas. So let's start talking about the comment ranking system layer architecture. So I put a funny picture here, just saying this is the abstract form of the architecture. So the real system will be much more complex than this. So let's take a look at this. So I divided the comment ranking system to two parts. So the left parts will be the post operation, like those posting comments and stuff like that. And the right part will be the get operation. Those are people viewing comments and ranking comments. And also I divided to the offline and the online. So the left side are mostly offline operations and the right side are mostly online operations. So let's take a look at layer by layer. So what happened when you post a comment? So when user posts a comment or click like or post a reply, it will form a request context, user information, video information, client information, and the comment you posted will go through this event tracking pipeline right here. And the event tracking system are processing those comments asynchronously. So you will write to this event Kafka. And this event Kafka will be consumed by two services. First is the comment review pipeline, and the second is the comment update. The comment review pipeline contains a bunch of NLP models. Those NLP models will process this comment, like give scores such as sentiment score, trust, like root score, badness score, and those scores will be used to determine if this comment can be exposed to public, and those scores will also be used for comment ranking feature. So this comment review pipeline will write out the comment Kafka, then save all the features to this comment feature and comment counter data storage mid layer. And I also put a batch inference here. So the comment review pipeline will get scores from model inference services, which is the bottom layer, the machine learning and AI service layer. So in this layer, it contains NLP model training to offline evaluation to model inference services. And also we have labeling services, embedding services, and model hub. Model hub is just like a GitHub for code, but it's a GitHub for models. So this part of offline AI services will provide batch inference so that the comment review pipeline can process those quickly. Okay, now let's take a look at the right side. So what happens when you screen through your TikTok videos and click the comment section. So you will initialize the get operation. So the get operation will call the ranking services and return a set of comments ranked by our models. So this inference usually happens in real time. So it's in within 100 milliseconds. So in the business layer, this ranking service consists of recall stage, a general ranker, a personalized ranker. And this personalized ranker will finally return data to the client side. And also you will write out training data Kafka to store all the online training data and do a streaming training for the personalized models. And those training services are supported by the online ML and AI services. So it includes online inference, GBDT ranking model, neural network ranking model, parameter server, model monitor, feature monitor, online training, and A/B testing. So those are accomplished in the AI service layer. So I just one thing to highlight is that between the AI service layer and the business layer, there's a distributed cache. So what the distributed cache does is that it separates those two services so that even if there's something goes wrong with the machine learning service, the model score, the user embedding the common features, they can still be accessible by the rankers, so that even if there's something wrong with the backend, the user can still see comments, they can still get model scores, and they can still get reasonable ranking. And finally, at the bottom, there's a data management layer. So data management layer is consists of data warehouse, data version control, data synchronization, business intelligence, and data analysis, and Hadoop file system. So this supports everything above it. Okay, so my presentation today will be, we'll talk about how a ranking system works. So just keep this architecture in mind. So let's get into it. So let's start with NLP models. So NLP model is one of the most important part of our ranking system. It provides features and for our rankers. So there's 3 phases when we're developing an NLP model: the train and the inference offline, and write model score to distributed storage, and then finally scores is used in the ranking stage. So there are 2 types of model we use, BERT and XLM-R. So for TikTok, we are a multilingual platform. So naturally, XLM-R might be a better choice. So, but both of these models architecture have advantage and disadvantages. So BERT is used mostly for single language, and you need to maintain multiple models to support multilingual. And for some language that have smaller corpus, it's harder to train a good BERT. And finally, embedding on different language are not comparable because they're training on different models. However, XLM-R has some advantage over this. So it's able to learn multiple languages. We only need to maintain one model and compare the performance of one model. And we can easily learn on low resource languages. Also, there's 1.6% performance increase on Golang, according to the paper. Okay, now for the ranking services. I mentioned in the layered architecture slide, the ranking service contains recall, general rank, and personalized rank. Each part uses a certain type of models. So let's start with the recall stage. So what the recall stage does is constructing a common candidate pool. So like for many videos, we have hundreds, thousands of comments. We cannot possibly return all of them. So we cannot possibly run all of them through a ranking model because that will be very, very expensive. So what we do is we use certain recall strategy to construct this candidate pool. So the candidate pool will be, you can think of the candidate pool as a common index database where the video ID will be the key and a bunch of common ID will be the value. So the goal for this recall stage is to construct this common index. So here's how we do it usually. So we have multiple ways. First is the recent common cache. So recent common cache contains all the comments that posted recently. They're ranked in timely order. And then we have the hot common cache. The hot common cache are those being interacted the most, being liked the most, being replied the most. So this will save in the hot common cache. And finally, we have this cold store comment. So cold store comment is a little different. So we will train a cold store model that will take when you post a comment, it will run through the cold store model and it will give a score. Whoever ranks the higher in this model will be put into the cold store common cache. And finally, those three cache combined will become a common candidate pool. And then we will remove the same common ID and then put into recent common, hot common, cold store common, and save everything into this common index. We only save the unique common index. So we'll merge them and save the unique common index. And after the recall stage, we have the general ranking stage. So the general ranking stage is usually a relatively simple model, such as logistic regression or GBDT or shallow neural network. So for our use case, we used GBDT. So the general ranking model, we gather online feature through the contains user actions, text feature. Those are text feature are NLP scores, and video feature. So those are scores produced by the video models. And then we have viewers feature. Those are like viewer statistics and others feature. Others feature also other statistics. So we combine them into a dense feature layer, and it will go through a model, a GBDT model, to predict the likelihood of this comment being replied or the comment being liked, given current stage of information. And then finally, the model will be evaluated on AUC or group AUC. So here I want to mention this group AUC because AUC doesn't reflect the performance of our model as well as group AUC. So group AUC group AUC are more aligned with online performance, like through A/B testing. So usually we'll use group AUC as the final determined metrics for offline evaluation. Okay, and after this general ranking stage, now the comment have certain rank, and we will put the top ranking comments to a personalized ranking stage. So this, this very complicated model is the personalized ranking model architecture. So, so this personalized model contains trained parameters and freeze parameters. So freeze parameters contains like other UID embedding, text embedding, and video embedding. So those are 256 long vectors, and they're concatenated together to represent other information, text information, and video information. So the trained parameters contains viewer user ID. So that's the viewer's user embedding, the user's action, and others. So everything will be put into this array, embedding array of certain size, 64 or 256, depends on how you structure the model. And everything will be then concatenated into this dense layer. And then you will go through this deep tower. So the deep tower is a shared parameter that will be updated by each of the action towers. And each action towers will be modeling certain user action. We'll be modeling one unique user action. For example, like, reply, share, or something like dislike. So you can put multiple action towers. So I just listed 4 here. And then there's a lost weighting layer. So what the lost weighting does is that, some actions are more sparse than other actions. So you want to weight those losses so that the shared parameter, the deep tower part, can learn from each action relatively balanced, in a relatively balanced way. Otherwise, the shared parameter, the dense layer, the deep tower, will only learn from the more more dense actions such as like or reply. So those are actions with high penetration. But for lower penetration like report or dislike, you will not be learned as well. That's why I have this loss weighting there. And finally, after the loss weighting, we have the final loss, and this comments will be ranked based on the final loss. And then finally, it will return to the user. So let's get back to the layered architecture. Now let's get back to the layered architecture. So the NLP model training, we're using XLM-R. The general ranker here is the GBDT model. The recall stage, we're constructing this common index, and the recall stage have co-star models. And the common index is separated from, so the recall stage doesn't directly feed into general ranker. We separate, we're storing this in a common index cache so that even if the recall stage fails or having some engineering problem, we can still provide comments for the online ranking services. And finally, the personalized rank. Personalized rank will rank top comments generated by the general ranker and give user the best experience. Okay, I think that that's all I want to talk about today. Thank you for coming. Again, thank you for coming. And you can find me at LinkedIn, or you can ask me any question through LinkedIn. Thank you.